Okay, so good morning, everyone.
Good morning. Oh, you're hiring. Yeah, you do.
So very quickly, this is what we'll do. First of all, thank you for submitting yourself to be my student today. That's the first thing we're going to do. You're going to go through what it looks like to be in my classroom. And then I'll talk to you guys a bit about the next generation science standards, which New Jersey as a state has adopted, and we as a private school has chosen to adopt because I think it's a very good set of standards. And then I'll tell you how the middle years program really take it to the next level. So the standards is great, but MYP really brings it to the next level, and I'll explain what that means. All right, so first of all, science learning in today's classroom is all about phenomena. Why bother learning science if you cannot explain the world around you? So for every single science lesson, we are grounded in a phenomenon. So for example, the phenomenon that you guys will be experiencing today is this. Lunar eclipses last longer than solar eclipses. So it's not just a matter of learning about lunar and solar eclipses. You need to know why. What does it help us explain? And so if you go through my lesson today, hopefully you can explain that phenomenon in your own words. So every time they come to classroom, basically there will be a phenomenon on the board. They write it down, and then they have to ask questions. So the great way about this framework is I give you the phenomenon, but you have to come up with questions so that at the end of it, you can answer it. It gives them the motivation of why should I learn this? And whenever I ask them to ask questions, it's not like, okay, just ask any questions you want. It has to be directed. So, and it's actually not trivial. So try it yourself. I have paper and pencil. Ask questions about the cause of lunar and solar eclipses. And I will explain a little bit more later, but there's a significance to the blue and the green. But anyway, since you're adult learners, I'm sure you can do this quicker than my students, so I'll give you exactly 1 minute to grab a sheet and come up with questions, not answers. I don't want facts. I want your questions about the cause of lunar and solar eclipses. Cool.
There's more things we have in this brain. You need quiet and silence in class. If you need, yes.
Olivia, George, thank you. Thank you, Ms.
You know what? I'll bring it more. Oops, sorry, everyone. Is that better?
就把它再推过来一点，电视再推过来，这样它不会一直太靠近那个 speaker，yeah， 它不会一直流，不会太靠近那个 speaker。
Is the computer optional? Like, am I supposed to go on the computer?
That's for the second task. So each of these are called performance tasks. The first task is to ask questions, and then when you are ready, when you have, say, 2 questions down, then you may pick up your Chromebook and go to the next task, which is obtain information from the reading.
Sorry, don't write on top of it.
Okay? And everyone has a computer because you and your partner will not do the same reading. Because that's another thing we encourage. We encourage talk between, whether as a group or as a partner. So you cannot do the same reading as the person next to you. But you have to have at least 2 questions down first. You have to do work. You have to do paper.
The 2 learners here.
Your students do have to start doing stuff like this by 8:45 in the morning, so it is 10:45. So you guys have 2 hours to wake up your brains.
Wait, I'm sorry, what are we supposed to do?
So the first
As always,
don't worry, in September it was exactly like this. By now your students have a lot of practice. The first thing you need to do is ask questions, so don't give me facts. Ask questions about the cause of lunar and solar eclipse. And here's a hint. Usually when they start off, they're like, I don't understand what you mean by cause. I'm like, that's okay. If you don't know how to go there, just ask. Do you know everything about lunar eclipse? If you don't, ask me something you don't understand about lunar eclipse. Or the simplest question is, what is a lunar eclipse? So if that's where students are at, I'm okay with that. But as we move along the program, I expect that they can come up with more sophisticated and direct questions about a certain concept. Yeah. Okay, so we do have to move on. So the next thing we have to do is you and your partner have two readings. One is about a lunar eclipse. I've already set it up. And the other about a solar eclipse. So you have to do your own reading. So if your reading is lunar eclipse, do that reading. And your partner will do solar eclipse reading. And then you have to discuss, what did you find out about lunar eclipse versus solar eclipse? What's the difference between a lunar and a solar eclipse? So do your reading and then try to discuss with your partner, what does solar and lunar eclipse mean? What is the relative position of the sun, earth, moon during an eclipse? So I'll give you guys 3 minutes. So you can, okay, so open up your Chromebook and the reading should be there already.
We are not allowed to use the phone in the classroom. You have to put the phone to the office.
Which they trust
No.
you, right? Lunar eclipse is black moon and solar eclipse, so I trust you that that is true, right?
That's right.
And then you are putting it on this computer, and then how does the child know, like, this is a CK12 org? This is what you have chosen
I
to show
picked
on
for
the
them.
computer, right?
Correct.
So this is like if you handed me a textbook, right?
Exactly. And in fact, this is like a textbook, this particular website.
Do they
And
ever ask you, like, oh, well, what is that? Like, how do I know? Or anything like that?
no, they've not asked me about like the authenticity of like a resource.
Okay.
Because they to them it is like a textbook. It's basically in my science class, I more or less rely 90% of the time on articles from this textbook. And of course, before I give it to them, I read it and make sure it's true, the facts. What I like about this particular website is it allows you to search based on grade level. So I know these articles are appropriate for grade level. If you scroll down and check details, it actually says for grades 6 and 7 or something like that. So I know that this is level appropriate.
And so, like, you've already read this.
I have. And in fact, the great thing about this particular website is almost like a little bit open resource. So if there's anything I don't like the phrasing, I can actually edit it.
Okay.
And I become almost like an additional author on that.
Right, so nothing that they look at on here that you haven't looked at first.
That's
or
right.
you haven't.
That's right.
Because one of the problems I see is that they all seem to think everything that they see on the computer is
Right.
true all the time.
And that's where I tell them when they do their research, like Wikipedia, you have to be very careful. Not only the level is not appropriate sometimes, but the information is not correct sometimes. Yeah, but definitely I vet all of
So I
the.
trust you, I'm gonna read it, so it's true.
So once we're done reading, what's the next thing?
So then you need to discuss with your partner, what does solar or lunar eclipse mean? And what is the relative position of the sun, earth, and moon for you? I think it was solar.
Lunar.
And for him, solar. So if you could guys start discussing with your partner in maybe about 30 seconds.
Yeah. Yeah, exactly.
At one point they all came along.
Yeah.
Let's try this again.
Yeah, well.
All right, my class.
No, we have many questions. No.
Let's move on. That's actually a signal for my students to give me back their attention.
I think we need a blue slip. Blue slip.
So again, in my classroom, they would be given far more time. Okay, we are doing an accelerated pace because I have to be done by 11:10 or something like that. So we are going at like this fast clip, okay? So I apologize for not giving you more time. This is a phenomenon. And also very relevant to our students today because most of them can still remember that 2 years ago, over here in New Jersey, we did experience a partial solar eclipse. So a lot of them remember that incident, expression get lines. So whenever I pick phenomena, I try to pick one that is interesting and relevant to them. But very, very quickly, okay, because there's another activity. I just wanted to show you guys like the variety of stuff we do in the classroom as they explore phenomena. That's why I'm doing this like real quick clip. We always start with questions. Most of the time, I would say like 95% of the time they will have a reading. If you think back about our schooling in science, it was always the teacher lecturing. Not anymore. Now we want them to find the information themselves. Now, this particular reading is not difficult for them. And so for this particular phenomenon, I allowed them to do exactly what you're doing. Some readings, because they haven't been exposed as much to them, for example, we've been learning about density, we don't do that reading on their own or in pairs because there's just too many words in that particular reading, even though it's at their level, that they wouldn't be able to understand as they read. So in those cases, we read as a class, in a sense that everyone will be looking at the same reading. I will call on students to read maybe a few sentences and then another students, but as they read, we pause, we try to take in stuff. So it really depends on the particular reading that they have to do. But most of the time, always ask questions, always obtain information, and then a quick discussion. So, let me see. Would you like to tell us what an eclipse mean? Based on the reading, like a general idea, what is an eclipse?
Well, I was looking at the solar eclipse, so it's when the moon passes between the Earth and the sun, and it can be either a partial or a full, and it will depend on like where you are in the Earth.
Absolutely. But what does an eclipse mean? Anybody have an idea?
When three objects are in the linear position and one is blocking the other one.
Okay, so I like that word blocking, okay? So whenever there's an eclipse, something is being obscured. So one of you did solar eclipse, one of you did a lunar eclipse. Think about the words solar and lunar, and this is where I like to go into etymology also sometimes. So why is a solar eclipse a solar eclipse? What is being obscured?
The sun.
The sun.
The sun.
Right? Because sol means sun. So a lunar eclipse means the moon is being obscured because luna comes from the word luna, L-U-N-A, which means moon or month, right? So that's one thing. That's how we try to help students remember. Because if you know where it came from, then it makes more sense. Okay, so if in a solar eclipse, it's the sun that's being obscured, why? So you guys read about the relative position of the sun, earth, and moon. Why is the the sun being obscured in those incidences? What is happening?
The moon is blocking it?
The moon is blocking the sun, right? And so because the moon is blocking the sun, during a solar eclipse only happens during a certain phase of the moon. What phase is that? Because it's the sun, moon, and earth, it can only happen during a certain phase of the moon. What phase is that?
You said a new moon?
A new moon, right? Because so the sun is here, okay, we have the earth and the moon, okay, earth and the moon, right? When the sun is here, right, this is the part that's facing the earth, right? This is the new moon. That's why it's a new moon, because the sun's light is hitting the back of the moon actually, and therefore we cannot see the moon, because it's not reflecting the light of the sun. And therefore, in a lunar eclipse, what phase of the moon is it? Anyone has an idea? It's actually the opposite, right?
Yeah.
So it's the full moon, right? So here is when there could be a solar eclipse, and here is when there could be a lunar eclipse, right? Okay. So that's the relative position, sun, moon, and earth, and it's not necessarily easy for them to get that. So I have another activity, would you guys like to do it? Is where you actually use physical stuff to model a solar and a lunar eclipse. Okay, so I'm going to turn off the lights. What we have is, so it'll be groups of three, and I think you guys are situated very nicely as groups of three. Okay, what we have is a flashlight. Okay. We have a larger ball and a smaller ball, and the easiest thing would probably be to keep this steady like that, okay? So, what does the flashlight represent? Sun. Okay, source of light, right? This represents
Moon?
Earth.
Earth. Why do I use this to represent Earth versus this, the moon?
Size.
Size, right? Earth is bigger than the moon, okay? And why do you think I would prefer to put this in here and this standing alone?
So you're going to change the position of the moon.
That's right, the moon is orbiting the Earth, okay? And so in your groups of three, so you guys don't mind splitting up, okay? One person has to hold the sun steady, okay? And one person has to hold the Earth steady, and the other person has to get the moon orbiting around the Earth. And what do you think you need to try to observe as you do this demonstration or investigation? In order, shadow, I love that word. So try to see where shadows are appearing or land as you run this investigation.
I have a question about the moon, like the new moon and the, I don't really, I understand like when it's a new moon, the ocean is both different. Like, I don't actually understand other than how it looks. What it is. So there's a circle. And what does that mean? It's turned. Can you show that?
How about you try to show that to yourself? I'll come and help. Oh, wait, you guys have one.
Because we don't have the umbrella.
That's right. That's right. Because of yeah, go ahead. I'm gonna go to my other
Yes, that it's turning like this.
We have a question.
Yes.
Remember the equator is the hottest, remember?
Yeah,
It's turning like this. Turning like this.
There's still light.
So that's the equation. Our question is,
This is the
what's the
equator right
difference?
here.
So, no, I think lights go up. What's the difference around the new moon and eclipse? Like, so if it's here, it's dark, right?
Yeah, that's only because it's lined up.
Right.
That's because it's lined up. We don't see eclipse at every full moon because the usually it's not entirely lined up, right? I mean, it's very small, but usually it is.
Played out.
Right, the moon is not orbiting at the same plane, it's on a tilt, and so is the Earth actually. So if this is the plane of the sun,
Yeah, so here it's.
the Earth actually orbits like 7 degrees, and then the moon itself also orbits at a different degree. So it's only very rare that they line up, which is why the eclipses are rare. Otherwise, you should see them at every full moon.
Calculate, like
Yes, you can calculate. Yeah, because if you know the orbit.
After the new moon, it goes to this
So that's like the quarter moon?
quarter or maybe like.
It depends on the type of lesson. Some I will, but some of it is definitely not in their reading. Then I will tell it. Yeah. I mean, because there's only a limited amount of time. So I'm okay with sharing some stuff, but some stuff, the things that I really want to get the picture, I will guide them to get there. If they have some reason science. That's not on a day-to-day basis. If it's a research project, then yes. But in terms of the phenomena, usually not, because I study them every day, and I've already vetted them. Okay, so 3 steps to a science lessons. Always start with a phenomenon, and then they have to gather information of the phenomenon. They have to reason. So it's one thing trying to learn the information. It's another thing if you actually understood it or not. And so most of the time, I ask them to reason it in some ways. A lot of times, it's coming up with a model. So what I would tend to do at this point is say, don't look back at the reading. Okay? Based on the reading you've already done, and sometimes it is usually something that you have to do for homework because we've already run out of time. Because we spend all this time in investigating, in discussion, right? So this is oftentimes their homework. Okay, now you have all this. Don't go back to the reading yet. Come up with a model. Draw a diagram with description. That's always the difference between just a diagram and diagram with description. A model has to explain something. If you just give me pretty pictures and I don't understand what you're drawing and there's no description, it's not a model. Your model has to explain something, okay? And usually the model has to be about something specific. So your model should show me the relative position of the sun, earth, and moon, and how these causes a solar and lunar eclipse. Do I have time for them to try it out? I don't think so, right? No, probably not. Anyway, that's something they would have to do, okay? And then I try to get them in different ways, so they love watching videos. So I normally would select a good video if it's relevant, and then ask them to summarize it in some ways. And the final one is communicate. That's the third thing that NGSS really stressed about. You have to be able to communicate your ideas. You have to be able to share and be able to receive feedback. That's something we are working on.
Is that in Chinese?
Oh, no, science is all in English. Sorry.
You're middle school, right? You're in the middle, I know.
I'm a middle school science
You're the
teacher,
middle school
and
science
I don't
teacher.
speak Chinese well enough, so I teach everything in English. Everything's in English.
But you also are overseeing all the science.
That is correct. I oversee science in elementary school grades, so I work with pretty much all the teachers in helping them develop their science lessons in this format. Mm-hmm.
Yes, and for that language model, for math, it's in Chinese, but for science in English. Because science have a lot of terminology terms, it's very, very different. If you know Chinese, we talk about cell. Everything have a keyword is the same. It's so easy. But with the English, they have to pass their some terminology. Then that it's easy to learn from English and understand the concept when they take the standardized class and understand these key long words means what
Yeah, no,
kind
I'd
of
rather
science.
have it.
Yeah.
Science is its own language.
Yeah.
Even with like the 4th and 5th graders, the science I do with them, the vocabulary is so broad that it's its own language itself. So
Yeah, and so in the past when I was growing up, your test is multiple choice, right? You know the facts, you get the answer. Not anymore, not today, right? So after learning about solar and lunar eclipses, if you understand the concept behind it, then you can explain something like that. So this will be a kind of question I would give them on a test. Explain how lunar and solar eclipses can provide us with information about the sizes of the Earth and Moon. So you have to say, okay, well, solar eclipse lasts a short time because moon's shadow is very small versus lunar eclipse, it lasts a long time. Because Earth's shadow is much bigger, therefore we know that the moon is smaller than the Earth. So that's the kind of thing.
Pencil and
Yes.
paper?
Yes, yes. Okay, and very briefly, NGSS. So it's what they call three-dimensional science learning. So for every phenomenon, we have three spokes to it. Okay, we are always grounded with the core ideas. And what I love about NGSS, they have a progression. They have the core ideas all the way from kindergarten all the way to high school. So I know where my students need to be right now in middle school. So these are the middle school core ideas. I know what they should have learned in elementary school, which I'm not showing here, but they do have it. And then where they're going forward in high school. So the progression is very clearly stated. I know my boundaries, like where I shouldn't take them. I know where I might need to buff them up if they didn't get enough from elementary school. The cross-cutting concepts are the stuff in green. So for every performance task, for every task, there has to be a concept related to it. So the concept that we emphasized in today's phenomenon was causes. And there's always the practices. The practices are basically the three things. They need to gather information, they need to reason with the information, and then they need to communicate. And there are, I think, about 10 to 12 practices that they want students to be really familiar with. Okay, so this was the core idea that we were working on today about how the model of the solar system can explain eclipses of the sun and the moon. So again, even in the core ideas, it's not a bunch of facts anymore. It's really what you need to be able to get from it. What can you explain? Because science is all about explaining the world around us. It's not memorizing of facts.
Which grade do you start teaching?
6. And I would say, I mean, I'm sure you won't really want to do it, but if you look into the core ideas, some parents are taken aback. How come science in middle school is so much harder? Well, if you look at the core ideas, it is that much more sophisticated. They might have, actually, I forgot how many the count is, maybe like 50 core ideas that they want covered in the whole of elementary school. By the time they come to middle school, they want you to cover 150 core ideas. It's that much more complicated and that much more.
Are there like beakers and test tubes?
Yeah, you're welcome to come down, but yep, we have
Bunsen burners.
Yep, we have graduated cylinders, beakers, preferably plastic because I don't want stuff breaking, but you know, some stuff we still have in glass, but yeah, we do have, and getting more because we have a wonderful science fund as well that we're using. So again, the NGSS, the focus is to make sense of phenomena, to explain the world around us. There's a big focus on engineering too, so I didn't get into that, but there's what we call engineering scenarios, where you give them a problem to solve, and they have to use the core ideas that we've been exploring to solve the engineering problem. And again, the phenomena that I try to pick for them should be specific, observable, applicable to science, and relevant. The more relevant to them, the more they're excited about. Okay, and very quickly, MYP. So again, NGSS, a phenomenal set of standards. MYP brings it to the next level. MYP emphasizes on transferable, enduring conceptual understanding. What do I mean by that? So in astronomy, you can explore a lot of phenomena. That was just one of maybe 7 phenomena we explored in the astronomy umbrella. But there's a unifying theme for that, and that is what I call the statement of inquiry. This is where MYP comes in. This is not NGSS. The statement of inquiry for our science unit currently is models can be used to explain patterns or processes within systems. So some of the questions I'll ask them after we go through all these phenomena. So why are lunar and solar eclipses a pattern? What is a pattern, first of all? What is the definition of a pattern?
Repetition.
Right. So why are lunar and solar eclipses a pattern? Is it repeatable?
Yes.
Yes, it's repeatable every time the Earth, Sun, and Moon lines up. Does that happen all the time?
No.
No, and that's an extra level. I didn't require them to understand, but it doesn't happen at every full moon and new moon. Why? Because of the way we orbit around the sun. It's not at the sun equators, but at a tilt. And the way the moon orbits around the Earth, again, is not at our equator, but at a tilt, right? So it's not all every month that they line up, right? But that's higher level thinking. That is, and it's not easy. That's where my 6th graders especially, they struggle with that. By the time they're 7th grade, they're much more comfortable with it. Or this one, this is a real kicker for some reason. I gave them this question. Okay, we did a kinesthetic activity where their bodies was the Earth, and they orbited and revolved around, they rotated and revolved around a sun, which was a helium balloon, shaped star. And I asked them, what daily pattern, explained by modeling the Earth as rotating about its axis? What's the answer? Day and night, sunrise in the east, sets in the west. Stars, moon, also rise in the east, sets in the west. What did my students answer? Seasons. Excuse me? No, right? If we rotated, but we didn't orbit, we have no seasons. So it's, again, a higher level thinking, right? It's making that connections. And what's great about MYP, the way they want us to utilize statement of inquiry, is the same statement of inquiry is transferable. It can be used in individuals and societies. Okay, can you come up with a model that can explain the process of a revolution? What happens? What are the steps that results in a revolution? You can model that. You can come up with those steps, right? And as Wen-Lin was saying, when I come up with this statement of inquiry, there is almost like a backward design to it. I first have to think about, okay, what astronomy phenomena I want to cover. And in those, what is the unifying concept? Systems. What's the related concepts? Models and patterns. What's the exploration processes? Then I put all these things to come up with a statement of inquiry. So there is a real, overarching framework for them where they can pull things that seem disparate, but really there is an underlying inquiry to it. And lastly, again, Wen-Lin touched upon assessment. This is a rubric. I did not come up with this. This is from the middle years program. Wen-Lin talked about achievement level. This is what she means, 0 through 8. So yes, this is a year 1. That means 6th graders are held accountable to this rubric. If they understood, for example, that phenomenon, then they can outline. They can give me a brief summary about what a solar eclipse means and the cause behind it. They can apply it. They can interpret information. This is the level of rigor that MYP gives to us. This is MYP. This is not NGSS.
So maybe a couple more sentences why getting a 4 does not mean 50%, you get 50% of the material, so it's not a mastery of content.
Right, as Wenling says, it's an index. So if your child got 4 out of 8 for a particular assessment, this is because, well, your child was able to recall scientific knowledge, they were able to do this, but they could not do that. That's where they're at. And of course, by the end of 6th grade, by the end of 7th grade, we want them to move from one index to another index, but that's where they're at that time of reporting, based on assessments we've done in class. Okay, let's see. One quick thing. Please, if you can make it, middle school science fair, which will only involve 6th and 7th graders this year, will be on March 1st in the afternoon, 1:30 to 3:30 p.m. If you are interested in being a judge, please let me know. And we have a couple more science events coming up, but I'm not going to overwhelm you. You will receive emails. If you're a middle school parent, you will receive some emails. There are a couple things I would like to happen, but I might need your support for them. I think I got it. Okay?
Yeah.
All right.
Okay.
I'll stay back for questions after.
Why not 8th grade?
Because they have a community project. So in 8th grade, they have a project.
Optional.
Yeah. So science fair was optional, and no one took up the option.
Yeah.
We might change that next year.
But it's a huge commitment for them to do the community. It's a very culminating project.
Yeah, it's
And
sort of
it
like
runs
exhibition
year-long.
in PYP, but in MYP it's much more self-driven,
Yeah.
right? More so than even the exhibition.
Yeah, yeah.